this is part 2 of navigating around Vernier Graphical Analysis software. In this part, you will learn how you can linearize a graph and how you can sketch a max and min line. So to be able to do that, and keep in mind, this is not only for this experiment and type of motion, but you can use this in general. When you have an equation that is otherwise non-linear, and you want to linearize it, you kind of have to visualize and make a connection between the equations that you have involved in this motion. So in our case, we have two main equations that we are going to want to look at if we want to linearize our graph. First one being the equation of free fall, let's say, which is the following. And the other equation that you're going to want to consider in any other case would be the equation of a straight line, which is again, so now what you want to do is you can think of it as comparing coefficients, or actually comparing the variables themselves. The ones that you're going to have equal would be height and your y here are the same. Then 1/2 g, you can think of it as your slope, so it's going to be equal to m. And lastly, what you have remaining, and see here is not really that important, it's going to give you the y-intercept, so you can temporarily, if it's confusing you, delete it from here, because nothing's really going to change if you do this for visualization purposes. The last one that we haven't thought about yet is x and t squared. The relationship between the two is that they would otherwise be equal if t wasn't squared, because we know that for something to be considered to be in linear form, every coefficient or every variable should be raised to a power that is less than 2. So that being said, in the previous part, we have already plotted height against time. So now to be able to linearize it and bring it in this form, we want to plot height against t squared, because it's the same equation if you consider it the way that we just said. So that being said, and starting off a blank canvas, we're gonna input every other thing we had, which is gonna be your height, which is y, or h, whatever you want to call it. And then instead of t, you're gonna want to square every value and input it right over here. Now I skipped this part and the error bar part because it's the same. You just want to square them and then input the same error bars. And now we have essentially quote unquote linearized the graph, because a sign of confirmation is that you can tell it's kind of a straight line. Of course, it's never really gonna be an exact a perfect straight line. In other cases where you have more mistakes, it is completely normal to have what we call some outliers, which would be, for example, one point, for example, this point, being a bit further up, further down. Just in general, if you imagine a straight line over here, it would be out of the line, the range of the line. Even in that case, it is pretty much normal, and you can consider you can move on with sketching, doing the linear fit and sketching the mix and min and max lines. So now to actually sketch our linear fit, there are basically 3 ways to do it. I'm gonna show you the one I prefer because the other ones might need a bit more adjusting, and this one is just very straightforward and you cannot go wrong with it. You're gonna go ahead and go into Analyze, and then you're gonna go, the 3 ways I talked about is model, curve fit, and linear fit. They're gonna give you the same results if you are able to manipulate them in a way that gives you the same results, but I would suggest going with model. And now you can see we have this new small window opened. Here you can see a small version of the graph. Don't worry, it looks a bit messed up. I know it's just because it's scaled down so you can see it better. And what you want to do now, it's very simple. You go here to the general equation. As I said before, it is going to be the first one. You just have to check that it is the linear one. And now you may encounter the common quote-unquote problem that you don't see the line in the small window here. This happens every time. You just need to adjust your b value or the y-intercept so that it appears on the screen, and then everything becomes way simpler. Only thing you don't want to play around with is the slope, because it's either we're going to be calculated by the software, so you shouldn't really play around with it. So that being said, we're just going to play around with the values over here until it appears on our screen. I usually suggest going in a decreasing manner, so I will just lower it until I am able to see it on the screen. There you go, you can see it starts appearing. I'm going to go down until you can see it fully on the screen and press OK. Perfect, so now you have a line, but it is not lying on the graph. For you to be able to do that, you're going to have to go ahead and go over to this box and right click, linear fit options, and go down where it says enable line drag. This is gonna let you drag the line around and move it into a position that you want. This position, keep in mind, has to be very specific, because we want to do a max and min line. That they are very different. The max line means that over here you have the max y value, so it would start from the top, and from here you would have the minimum one, so from the bottom. That being said, we're going to drag this one up to the max one, the top point of the bracket. Essentially, what you're doing is looking for the top value, like the top line of the error bar, but the software provides you with this dark bracket so you can see better in like what you're doing. So now we're going to do the same, but this time we're going to drag it down from this side and we're going to drag it to the bottom one. Perfect. Now you have your line, your max line is ready to go. Last thing you're going to want to do is, for distinguishing purposes and not getting confused, you're going to want to go ahead and right click here, linear fit options. And first of all, disable enable line drag so you don't accidentally move it around and mess it up and have to do it all over again. And then you're going to go into appearance and you're going to change the color. So usually we go for red and blue. For the max one, I'm going to go for red this time. Now you can see it has all changed. And you can see it calculated your max slope. Now that you have done this for max line, you can go ahead and do the same for the minimum one. And you have your linear fit and your max and min slopes. Side note, if you want to calculate your uncertainty, you can go by the book and just subtract. This should be it in terms of linearizing and max and min slopes. If you found this video helpful, please consider dropping a like and commenting, and consider subscribing for more techie bites like this one. See ya!